Offline NDCG can crown the wrong ranker. Team Draft Interleaving lets clicks decide between two search systems with a much tighter comparison. You'll learn how the pieces fit into a workflow that interleaves search rankers and credits clicks to choose a winner. I'm Professor Pi, teaching search and IR with simple Python. Search teams often disagree because offline metrics can hide user behavior. You might see a higher NDCG for one model on a labeled set and still lose traffic when you deploy it. The problem is that offline labels and score scales are blunt instruments. Team Draft Interleaving gives you a lightweight online comparison that uses real clicks to reveal which ranker users prefer. At its core, the method builds a single result page from two rankers. The teams draft results into that page. Users click what they like. Then, clicks are credited to the team that originally drafted each document. Success looks like faster signaled preferences without running full A/B tests for weeks. The intuitive idea is simple. If both rankers can return the same documents, which system puts the things people click higher? Interleaving forces a head-to-head on the same page so you compare on equal footing. It reduces variance by turning many small impressions into a vote tally for one ranker or the other. We will walk through a small toy build that shows the whole loop. You will see how to compare two tiny ranked lists, merge them into a page, convert clicks into team credit, accumulate session wins, and run a conservative sign test at the end. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now let us first show the ranked lists and why overlap matters. This snippet compares two ranked lists before any online experiment and makes the overlap explicit. It shows which documents both rankers return and what the combined candidate pool looks like. The outputs labeled shared and pool appear on screen. Even with tiny lists, you get the core case Team Draft Interleaving handles. The same document can be retrieved by both systems, but ordered differently. Making this visible up front keeps later credit assignment tied to actual documents, not abstract score scales. And the overlap and pool sizes help you judge whether interleaving is appropriate. Now, we need to actually build the page a real user would see and fix which team owns each result. This example builds the team draft page a user would see and records ownership for each slot. The key move is alternating picks. Each side selects its top unused document, while owner tracks which ranker drafted every entry. That owner map prevents a common evaluation mistake. Once a shared document appears, it must be credited to exactly one ranker. To keep the teaching output stable, this version uses a deterministic draft order instead of full randomization. The printed merged page matters because clicks are interpreted against what the user actually saw, not against either original ranking. A displayed page is only useful when we can turn clicks into a signal. So next, we translate a user click into credit for a team. This code translates a user's clicks into a preference signal for a ranker. Since users click documents, not systems, we use owner to map each click document back to the team that drafted it. The margin is kept simple. Positive favors A, negative favors B, and 0 is a tie for that impression, which keeps interpretation local to the displayed interleaving, rather than mixing in offline labels or score magnitudes. The output shows the click margin and preferred ranker, and that atomic observation is what will aggregate across impressions. Single impressions are noisy. We need repeated sessions so the small signals add up cleanly. This snippet turns single impressions into a small experiment log so many noisy clicks can add up. Sessions collects repeated preference observations because one click can be misleading, especially for rankers whose differences are concentrated in a few positions. For each session, the code recomputes clicked ownership counts and appends assigned margin to margins. Then wins and losses tally sessions, where one ranker received more credit. So a single busy session can't dominate the comparison. The output shows session-level wins for each ranker, which matters because interleaving is most useful when many small preference signals accumulate quickly. Finally, we need a decision rule that is cautious but practical for limited traffic. Converts the accumulated team draft outcomes into a cautious decision. Rather than estimating absolute metric gaps like a full A/B, it asks a narrower paired question. Did one ranker win more interleaved sessions than chance would predict? The comb calculation gives an exact two-sided binomial tail under a fair win null using only non-tied sessions as trials. The decision rule stays conservative by requiring both statistical support and the correct direction. The output shows the exact p-value and decision, closing the loop from displayed rankings to a traffic-efficient comparison. In a product pipeline, you would map the page owner and click credit into your event stream. Each impression becomes a tiny vote in the experiment log. Then aggregate per query or per user cohort to spot consistent preferences before you ramp traffic. This method is a paired online test. Merge two rankers into one page and assign clicks to the drafting team. Use it when you want faster, traffic-efficient comparisons between two ranking systems without a full A/B rollout. One caveat: single impressions are noisy, so treat early results cautiously and prefer session-level aggregation. A practical next step is to run this interleaving on a realistic query log from your product and tune the page depth you show per impression. Changing how many results you include per draft shifts where ranker differences surface and can improve sensitivity to the changes you care about. If short, practical IR helps, subscribe and watch the IR videos.